Okay, so we were looking at various applications of the work energy theorem, and we had discussed certain conditions where work energy theorem in conjunction with these conditions. हाँ, होमवर्क क्या था दीक्षा, बताओ क्या क्वेश्चन दिया था मैंने? हाँ, L/8 हाँ, IIT वाला किया सबने वो क्वेश्चन. I hope everybody attempted it because IIT का क्वेश्चन था. आते हैं कंजर्वेशन ऑफ मैकेनिकल एनर्जी पे भी आएंगे. अभी फिलहाल हमने कंजर्वेशन ऑफ मैकेनिकल एनर्जी नहीं पढ़ा. हाँ, मैं पोटेंशियल एनर्जी बता दूंगा, फिर मैं बताता हूँ क्या होता है. तो जब तक सुमित सर बता रहे हैं तो सीख लो. So we have this distance as L/8. So the particle will go along the circle, and at some point it will leave the circle and it will become a projectile, and that projectile will follow a path like this. So the only way that the velocity of the particle will be horizontal while crossing the line is that this must be the highest point of the projectile. So this must be the highest point of the projectile. Okay. So again, the same procedure which we discussed. I, F. Let this angle be theta. Then velocity at this point is v. Velocity at this point is v naught. Excuse me. So if this angle is theta, then this angle is 90 minus theta. पहले बंद करके work energy between initial and final points. Summation of work is equal to change in kinetic energy. Summation of work is equal to minus mgl into 1 plus sin theta. Minus mgl is equal to final, 1 plus sin theta is equal to final kinetic energy minus initial kinetic energy. Right, so this is it. What we get from work energy theorem. Then we come to the circular motion at point P. Right? For the circular motion, I hope I don't need to but you should be doing this yourself now. Mg, this component will be mg sin theta. Mg sin theta is equal to mg square by L. does this give us? This tells us that V naught square is equal to GL sine theta plus 2GL 1%. Right? And now let's talk about the projectile. Well, for the projectile, it starts from this point. So this distance must be L cosine theta. And this distance must be half the range of the projectile. Right? If the topmost point is supposed to be here, then this distance must be half the range of the projectile. So therefore we get, for projectile motion, half the range. So half the range would be V square sine of theta, sine of 2 theta, because angle of projection is 90 minus theta. But sine of 2 theta is sine of 180 minus 2 theta, and sine pi minus theta is equal to sine theta. या फिर अगर आपको याद हो, कॉम्प्लीमेंट्री एंगल्स पे प्रोजेक्टाइल का रेंज हमेशा सेम रहता है. So therefore that will not make 90 minus theta will not make any will not create any problems here, divided by g by 2g, because we want half the range, is equal to L cos theta minus L by 8. I can put the value of V square here. GL sin theta sin 2 theta upon G is equal to L cosine theta minus 1. So GL cancels out and I get a simple, hopefully a simple trigonometric equation. Okay. Can you please solve this trigonometric equation and tell me the value of sin theta? Can you please solve this trigonometric equation and tell me the value of sin theta? 60 degrees आ रहा है? कैसे आ रहा है 60 degrees भाई? मैंने वर्कआउट किया है, तुक्का मार रहा है. क्यों? वाह, वेरी गुड. श्योर. गलत नहीं होना चाहिए सोना, गलत हुआ तो बहुत मारूंगा तुमको. Anybody else confirming 60 degrees? Shaunak has worked it out mentally. Sin theta sin 2 theta is equal to cos theta minus 1 by 8 by 2b नीचे. ये शौनक by 2 भी था यहाँ पे, भूल तो नहीं गया? मेरा 2 क्या है? वो भूल गया तो आंसर गलत. इक्वेशन का 2 बोल रही है प्रतीक्षा. क्वाड्रेटिक आएगा क्या? मेरे ख्याल से क्वाड्रेटिक आएगा ना, उसको सॉल्व करना पड़ेगा. या आई डोंट नो. Sin theta sin square theta है नहीं सही बताओ फिर से वही है 60 है क्या वाह शौनक जब हम मिलेंगे तो तेरे को एक चॉकलेट मिलेगा सो theta without solving trusting your words theta is equal to 60 degrees and if theta is equal to 60 degrees now you can work out the value of v naught क्या आएगा आ जाएगा ना you will be able to work it out right some complicated expression it won't be that complicated but still GL into something something root 3 क्यूबिक आ रहा है क्या बोल रहा है भाई डराओ मत भाई हाँ cubic equation you know how to solve na? It is not a very big unless of course you can't हाँ हाँ 60 है आंसर 60 है unless you can't find the root by inspection then you are in trouble with a cubic but whenever you get a cubic in all probability you are going to immediately find one root by inspection and the moment you have found one root then you can divide to find the other तो किया होगा ना क्लास 10th में ये सब नहीं करवाते हैं क्या डिवीजन ऑफ पॉलिनोमियल आई थिंक करवाते हैं आंसर बताओ भाई कोई तो वर्कआउट करेगा कोई नहीं GL root 3 by 2 plus 2GL 1 plus root 3 by 2 GL root 3 by 2 plus 2 plus root 3 GL. हाँ, thank you. 2 plus 3 root 3 by 2 यहाँ तक छोड़ देते हैं अब, यहाँ तक छोड़ देते हैं. Right, so this was the हाँ v का वैल्यू बताया ना. Yes, yes, yes. अच्छा v बता दिया क्या? चलो, so I'm changing the slide. We are going on to the next question. As you can see, this is very complicated, so I want to spend some time on it, and I want to cover as many types of questions as possible. Okay, so we have two small spheres of mass m. Small का मतलब ये है कि the thickness of the tube can be neglected. They are kept in a vertical circular tube of mass capital M and radius r. ट्यूब का रेडियस भी r है, जो particles का circular motion होगा उनका भी radius r. They are released from the topmost point as shown. Now, as they move down, you have to find the normal reaction between the sphere and the tube as a function of this angle theta. And then you have to find the ratio of masses, okay, ratio of masses, so that the tube jumps up. Right? Jumps up का क्या मतलब है? What does it mean, jumps up? And I mean purely in a mathematical sense, right? उसका physicality क्या है, क्या नहीं है, उससे मुझे कोई मतलब नहीं. Mathematically इसका मतलब क्या हुआ? Very good, Shana. Yes. Mathematically इसका मतलब हुआ that the normal reaction between the tube and the floor, okay, normal reaction between the tube and the floor at some point becomes Z. अगर ऐसा हुआ, then that means that the tube has jumped up. So please try this. नहीं पात. एक्शन रिएक्शन पेयर से कोई थोड़ा मतलब होता है शौनक. मैंने तेरे को थप्पड़ मारा खींच के, फिर मैंने बोला कि अरे शौनक एक्शन रिएक्शन पेयर तो जीरो होता है ना, तेरे को दर्द क्यों हो रहा है? ऐसा तो नहीं होगा ना. मैं तेरे को मारूंगा तो मैं तेरे ऊपर फोर्स लगाऊंगा एंड यू विल अप्लाई ए फोर्स ऑन मी. तेरा गाल दर्द करेगा, मेरा हाथ दर्द करेगा. बट द पॉइंट इज दैट two equal and opposite forces have acted on two different objects. So you can never sum up, you can never say that summation of forces is zero. You can only say that when you have considered the whole thing as a system. वो हम नेक्स्ट चैप्टर में वही पहला काम वही करेंगे कि इंटरनल फोर्सेस का क्या मतलब होता है और एक्सटर्नल फोर्सेस का क्या मतलब. So I'll give you a hint. Okay, I'll give you a hint. We did a question in the last class where we got an answer cosine inverse 2 by 3. What happens at cosine inverse 2 by 3? मैं हिंट दे रहा हूँ, सुनो पार्थ, मैं हिंट दे रहा हूँ, मेरी बात सुनो. कोसाइन इनवर्स 2 by 3 पे क्या हो रहा था? कोसाइन इनवर्स 2 by 3 पे क्या हो रहा था? What was so special about cosine inverse 2 by 3? Ball leaves the surface, right? Ball leaves the surface, particle leaves the surface. Now, in the question that we discussed in the last class, when the particle leaves the surface of the hemisphere, it is going to go in a projectile motion beyond the hemisphere. But what is going to happen here? The particle cannot fly off. So, in light of the question that we did, where we got the answer cosine inverse 2 by 3, right? Can you tell me what is going to happen here? Part of सही निकाला. Can you tell me what is going to happen here? The normal reaction on these spheres will be due to the inner surface of the tube up till cosine inverse 2 by 3. And beyond cosine inverse 2 by 3, the normal reaction on the spheres will be due to the outer surface of the tube. Right? That is what you have to realize. So whatever answer you get, whatever normal reaction expression you get, for cosine inverse 2 by 3, it should become 0. For cosine inverse 2 by 3, it should become 0. That is the check. And this is valid for all circular and spherical and hemispherical surfaces. हाँ, उससे मैटर नहीं करता है तो अगर मैं एक ब्लॉक को ऐसे रख दूं दीवार पे, so this is the block, then the normal reaction here will be 0. Normal reaction is induced. हाँ शिव, बिल्कुल सही आंसर. Normal reaction is induced. हाँ, ठीक है. Normal reaction is induced. Normal reaction is caused by something. Right? We forget about it because gravity is so ubiquitous. Gravity is always there. So we forget about it. But the fact is, I think ये किसी ने मुझसे क्वेश्चन पूछा, प्रतीक्षा ने शायद पूछा था क्वेश्चन कि अगर अर्थ की ग्रेविटी गायब हो गई तो क्या होगा? कुछ नहीं होगा. नॉर्मल रिएक्शन 0 हो जाए. हम वहीं के वहीं बैठे रहेंगे. We will be as it is. We will not be disturbed in any way. नॉर्मल रिएक्शन 0 हो जाए. क्यों? क्योंकि अर्थ की ग्रेविटी ने हमको नीचे खींच के रखा है, इसलिए नॉर्मल रिएक्शन. There is a normal reaction between us and the floor, between us and the surface, right? And here also, up till cosine inverse 2 by 3, because of the fact that gravity is acting, the normal reaction will be between sphere and the inner surface of the tube, and beyond cosine inverse 2 by 3, the normal reaction will be between Pratiksha, you asked me some questions yesterday. Please remind me. अभी मेरे को क्लास में बताना है, ठीक है ना? I mean, those were very good questions. I have to tell everyone. नहीं सोना, गलत है. हाँ, बिल्कुल सही चल. अब सेकंड पार्ट ट्राई करो. आया कुछ हिंट मिल रहा है सेकंड पार्ट के लिए? नहीं, मैं करके दिखाता हूँ. So these are questions that you have to be able to do yourselves now. First part के लिए, this is the tangential axis, this is the radial axis. Of course, there is circular motion. Forces acting on it are mg and n. This would be mg cosine theta, and this would be mg sine theta. Please notice that I have taken n outwards because I am assuming that theta is cosine inverse 2 by 3 से कम. So कोई फर्क नहीं पड़ता. I apply the work energy theorem between these 2 points. The work done is equal to plus mg into r into 1 minus cosine theta. So mgr into 1 minus cosine theta is equal to सेकेंड वाले का मेरे को आंसर याद नहीं है, पार्ट करके दिखा. mgr 1 minus cos theta is equal to final kinetic energy half mv square minus initial kinetic energy. But circular motion tells us that mg cos theta minus n is equal to mv square by r. So this implies that mgr into 1 minus cosine theta is equal to half into mgr cos theta minus. So therefore n is equal to 2 mgr 3 mgr cos theta minus 2 mgr. Now you may say नहीं नहीं मेरा तो साइन उल्टा आ गया, आंसर मेरा 2 mgr minus 3 mgr cos theta. nr by 2 nr by 2. So this will be equal to mg into 3 cosine theta minus 2. So now you may say that look, you know, I got the answer as 2 mgr minus 3 mgr cos theta. R nahi hai, sorry. And you are absolutely right. Because if you have assumed n to be inwards, then that would indeed be the answer. Because now you get mg cos theta plus n is equal to mv square by r. Both of us are correct. Okay? Both of us are correct. So I write it like this. I'm going to change the slide. Please take a screenshot. वो कभी भी गायब हो सकता है. अब मेरे को भरोसा नहीं रहा है नेटवर्क कनेक्शन पे. So I can write for theta less than cosine inverse 2 by 3, n is equal to जो भी एक्सप्रेशन हमने निकाला mg 3 cosine theta minus 2, and for theta greater than cosine inverse 2 by 3, n is equal to mg 2 minus 3 cos theta. course, you can ask what will happen at theta is equal to cosine inverse 2 by 3 and will be equal to 0. Right? Okay, now for the second part of the question. So, what we want is number one, ये मैं cosine inverse 2 by 3 की लाइन बना दी है मैंने. I want to know, and you have to answer this question. I want to know whether the normal reaction on the tube, okay, please notice the question. I want to know whether the normal reaction on the tube is inward or outward when theta is less than cosine inverse 2 by 3. Right? Please be very careful about the question. I am asking about the normal reaction on the tube by the spheres. Okay, I am asking about the normal reaction on the tube by the spheres when theta is less than cosine inverse 2 by 3. तो ये कोई बड़ी मिस्ट्री नहीं है. अगर स्फीयर यहाँ पे है तो स्फीयर के ऊपर नॉर्मल रिएक्शन ऐसे लग रहा है, इसका मतलब ट्यूब के ऊपर नॉर्मल रिएक्शन ऐसे लग रहा है. नाउ if the object, if the sphere is here, if the sphere is here, तो स्फीयर के ऊपर नॉर्मल रिएक्शन किधर लग रहा है? अगर स्फीयर यहाँ है तो स्फीयर के ऊपर नॉर्मल रिएक्शन किधर लग रहा है? वेरी गुड, यस. स्फीयर के ऊपर नॉर्मल रिएक्शन ऐसे लग रहा है. ट्यूब के ऊपर नॉर्मल रिएक्शन किधर लग रहा है? ट्यूब के ऊपर नॉर्मल रिएक्शन ऐसे लग रहा है. दिस इज ऑन द ट्यूब, दिस इज ऑन द ट्यूब. In which of these two cases, in which of these two cases will the tube jump up? ध्यान से. In which of these two cases will the tube jump up? In which of these two cases will the tube jump up? The answer is neither. नहीं, बिल्कुल नहीं. अगर आप इस ऑब्जेक्ट को फ्लोर से ऊपर कुदाना चाहते हो, want this object to leave the floor, तो किस डायरेक्शन में फोर्स लगाएंगे आप? किस डायरेक्शन में फोर्स लगाएंगे? डाउन. प्रतीक्षा, आर्यन क्या बोल रहा है? डाउन फोर्स लगाएगा तो ऊपर कैसे जाएगा वो? हाँ, आप सही बोला. राइट. In this case, on the tube, the normal reaction is down. The vertical component नीचे है. In this case, नॉर्मल रिएक्शन द ट्यूब इज डाउन, इसका वर्टिकल कंपोनेंट नीचे है। इन दोनों केस में ये ट्यूब ऊपर नहीं जंप करेगा। हैव आई मिस समथिंग? हैव आई मिस समथिंग? बताओ भाई, हैव आई मिस समथिंग? बहुत बढ़िया शिवेन, वेरी गुड, वेरी नाइस, यस, दैट इज व्हाट आई वांट, यस गुड। आई हैव मिस्ड हियर, यहाँ पे है ट्यूब, यहाँ पे स्फीयर। let me draw it a little bigger. So let's say that this is cosine inverse 2/3. यहाँ पे है स्फीयर। अब स्फीयर के ऊपर नॉर्मल रिएक्शन किधर है और ट्यूब के ऊपर नॉर्मल रिएक्शन? स्फीयर के ऊपर नॉर्मल रिएक्शन किधर है और ट्यूब के ऊपर नॉर्मल रिएक्शन किधर है? स्फीयर के ऊपर नॉर्मल रिएक्शन ऐसे होएगा, ट्यूब के ऊपर नॉर्मल रिएक्शन ऐसे होगा। ये आ रहा है सबको समझ में? Is this clear to everyone? Because यहाँ पे just before this yellow line, the inner surface of the tube was responsible for the force, and just beyond the yellow line, the outer surface is now responsible for the force. Because remember, अगर outer surface यहाँ नहीं होता तो ये particle छोड़ चुका होता surface में। Is this understood? बोलो भाई, yes or no बोलना पड़ेगा, नहीं मुझे नहीं समझ में आएगा। So now comes my next question. What is maximum normal reaction on tube in upward direction? Okay, please be very careful in answering. I want the maximum normal reaction on tube in the upward direction, in the vertically upward direction. What is the maximum normal reaction on the tube in the vertically upward direction? What will be the maximum normal reaction on the tube in the vertically upward direction? डी क्या है? नहीं नहीं तरुण, ज्यादा स्मार्ट मत बन। मैं ये थीटा के उसमें पूछ रहा हूँ। हाँ 2 करना पड़ेगा कि नहीं करना पड़ेगा बात? n max into 2 करना, 2 स्फीयर है ना। जीरो जीरो का क्या? नहीं नहीं, मालूम है ना, मैं इतना आसान क्वेश्चन नहीं देता हूँ। देखो, नहीं आ रही। देखो, n vertical on tube is equal to 2 into mg into 2 minus 3 cos theta into cos theta। ये कैसे आया? n on tube ये है, n vertical ये है, n horizontal ये है। एक स्फीयर यहाँ भी होगा, तो एक n on tube यहाँ भी होगा, और ये उसका वर्टिकल कंपोनेंट रहेगा और ये उसका हॉरिजॉन्टल कंपोनेंट रहेगा। वर्टिकल नॉर्मल रिएक्शन ऑन ट्यूब इज इक्वल टू दिस। एंड व्हाट इज द क्वेश्चन आई एम आस्किंग यू? मैं आपसे क्या क्वेश्चन पूछ रहा हूँ? क्या क्वेश्चन पूछा मैंने आपसे? नहीं, अभी क्या क्वेश्चन पूछा? अभी तो फाइनल आंसर देना है। मैक्सिमम एन कैसे निकालेंगे? यस, फॉर मैक्सिमम एन वी ऑन ट्यूब we will do d by d theta of 2 minus 3 cos theta into cos theta is equal to 0। हाँ शिवेन, अब सही निकाला। इसको आप डिफरेंशिएट करेंगे जब, तो यू विल गेट -2 sin theta, okay, plus 6 cos theta sin theta। This is equal to 0। Cos theta is equal to 1/3। Therefore, NV max on tube must be equal to 2mg, right? 2 minus 1 into 1/3 is equal to 2mg/3। ओके, अभी तक सब लोग फॉलो कर रहे हैं? ओके, so now I want to find this normal reaction n dash. कंपोनेंट लिया हार्दिक मैंने, ये नॉर्मल रिएक्शन का वर्टिकल कंपोनेंट, ये एंगल थीटा है, ये एंगल थीटा है। आया समझ में ना? I want to make the FBD for this. I want to make the FBD for this guy. So let's make the FBD mg, right? n dash n dash plus vertical component of n components of mg. Now what do you think should happen? When will this object leave? When will this object leave the surface? When will this object leave the surface? When n dash becomes 0. When n dash becomes 0. So if the loop leaves the floor, n dash becomes 0. This means that the vertical components of n should be equal to mg. For the boundary condition, maximum vertical component of n should be equal to mg. 2 by 3 mg should be equal to mg. M by m should be equal to 2. Right? Okay. Is this clear to everyone? कुछ clear हो रहा है? एक बार try it again without looking at the notes. Try this question again. I'm going to change the slide now. आगे चलते हैं, आगे बढ़ते हैं. So the question is, chain of mass M, length L, hangs from a table such that 2/3 is hanging. A force F pulls the chain completely onto the table. Find work done by F if this was done slowly. Okay, take a screenshot. स्क्रीनशॉट ले लीजिए. I'll come back to it anyway. हाँ, मैं सब बता रहा हूँ. स्क्रीनशॉट ले लिया सबने? Okay. Now keep your pens down. Keep your pens down, and I want to show you how this is done. But more than that, I want to show you the philosophy behind the question, which is much more important. Please pay attention to what I'm saying. So it turns out that in our world, there are two kinds of system. One is called the discrete system, and the other is called the continuous system. So what is a discrete system and what is a continuous system? This represents the real beginning of physics for you in class 11. And if you can grasp what I'm saying today, then you should have no problems in the future. So in physics, there are two kinds of systems. One is called the discrete system and the other is called the continuous system. A discrete system is that in which the components of the system are countable and discrete. Discrete का मतलब होता है individual. Rough translation. So a discrete system consists of objects which are distinctive, which can be separated from each other, which can be counted by the observer. Whereas a continuous system is a system for which the individual parts cannot be seen. You can't see any, you can't see the individual part. So this is how we will make transition from the mechanics of point particles to the mechanics of extended objects. अभी तक जो भी मैंने आपको पढ़ाया है सब point particles पे valid. इसको आप इस चेन पे लगाने की कोशिश करेंगे तो कुछ नहीं होने वाला, होएगा ही नहीं, सवाल ही नहीं होता। So I want to give you a couple of examples of discrete and continuous systems. If I have with me a glass which is filled with marbles, this system will be called a discrete system. Now what happens if I pour this glass of marbles over a weighing machine? And we are going to for the moment forget about the fact that the marble will fall and there will be an impact, and we will assume that when the marble falls on the weighing machine, there will be no bounce or no sound, no nothing. Weighing machine will simply measure the weight or the mass rather of the marble. So if individual marble has a mass of 100 grams, as I pour the marbles on the weighing machine, right? As I pour the marbles on the weighing machine, and I'm assuming that there is one stream of marbles, that means that two marbles will not land on the weighing machine simultaneously. What will be the reading of the weighing machine? The reading of the weighing machine will be 100 grams, then 200 grams, then 300 grams, and 400 grams. And if some sound is being made with the marbles falling on the weighing machine, and again, two marbles are not falling together. At a time, only one marble falls. Then an observer who cannot even see will hear the uh, fall of the marbles and will come to a conclusion, or will be able to conclude that, look, okay, fine, the number of marbles now that have fallen on the weighing machine are 1, 2, 3, 4, 5, 6, countable. Such a system is called a discrete system, and we have been dealing with discrete systems throughout the physics that we have studied. एक वेज के ऊपर ब्लॉक रखा है, डिस्क्रीट सिस्टम. एक लिफ्ट के अंदर आदमी है, डिस्क्रीट सिस्टम. Okay. Now I take a glass of water, and exactly like the glass of marbles, I pour the water on the weighing machine. Now let's say that the total weight of water in the glass is 300 grams. What will be the reading on the weighing machine? We are assuming it is a digital weighing machine. And again, we are discounting the effects of the water actually falling on it. We are just saying that the weighing machine will calculate the mass of the water that is existing on the weighing machine at any given time. Then what will be the reading of the weighing machine? Well, the reading of the weighing machine in this case will go up continuously. That means that the reading of the weighing machine will go from 0 to 300 without missing any numbers in between. That means that at some point of time, the reading of the weighing machine will be 20 grams. At some point, it will be 20.1 grams. At some point, it will be 20.13 grams. At some point, it will be 20.135 grams. In fact, depending on the accuracy of the weighing machine, कितने मैंने उसमें decimal places लगा के रखे हैं weighing machine के उस पे, I will get a continuously increasing reading going through each and every digit, going through each and every number, depending on, of course, the number of decimals that the weighing machine can read. Such a system is a continuous system. And again, if I draw the analogy with the glass of marbles, the observer hearing this, uh, you know, he will be able to tell you हाँ पानी गिर रहा है, but उसके beyond वो कुछ नहीं बता पाएगा, and the sound will be continuous, right? As you have heard, of course you have heard this sound of water falling. So in physics there are two kinds of systems. One is discrete and the other is continuous. Now the beauty of the thing is that the continuous system is actually also a discrete system. But the discreteness of a continuous system is so tiny that it completely escapes our senses. At the end of the day, we know that water is made up of molecules. But there is no way that I pour the water on a weighing machine and you'll be able to tell me, अच्छा इतना molecule गिरा है, अभी एक और गिर गया, अभी दो और गिर गया. No, you'll never be able to tell me that. So a continuous system is really a system which is discrete at a very fundamental level. ये बोलते बोलते मुझे कुछ याद आ रहा है, और किसी को याद आ रहा है क्या? When we were discussing calculus, I told you about शानक तो चुप रहा है, मुंह बंद रख अपना. When we were discussing calculus, I told you about the story of the matchsticks fitting on a curve. I hope everybody remembers. If you take a curve and if you start fitting matchsticks on the curve, फेविकोल और माचिस की तीली लेके, then you will find that the matchsticks do not fit the curve, and you can break the matchsticks into half and then again try the experiment. They will fit better but not perfectly. Then you can again break the matchsticks into half and again try. They will fit better than before but not perfectly, and you can keep on doing this. And we concluded that if the size of the matchsticks is extremely small, infinitesimally small, then the matchsticks will perfectly fit on the curve. Similarly, in integration, I told you that we want to find the area under a curve. So the way to do that was to divide the given area into little triangle, into little rectangles, teeny tiny rectangles. Find the area of a rectangle, add the area of all the rectangles, forget about the area जो हम नहीं count कर पा रहे हैं. That's it. That gives us the answer. So discrete and continuous is really the physics of calculus. What you need to be able to do is to convert successfully mathematically a continuous system into a discrete system. So basically, I will give you an object which will be continuous, and you have to convert it into a collection of infinitely many discrete objects, infinitely many point objects, or at least discrete objects. For example, right, I'll tell this example again later on, but for the moment, for example, I want to construct a solid sphere. Yeah, I want to construct a solid sphere. Now, I don't know how you think a solid sphere should be constructed, but I will tell you how I think a solid sphere can be constructed. So I will take a marble, okay? I will take a marble and I will uniformly paint the marble with white paint. बिल्कुल यूनिफॉर्मली पेंट किया व्हाइट पेंट से मैंने मार्बल को, और मार्बल को एक कमरे में पंखा चला के छोड़ दिया. एंड देन आई कम बैक द नेक्स्ट डे एंड तब तक व्हाइट पेंट सूख चुका है. एंड देन आई पेंट पिंक. pink paint, and then I leave it, and then I go back, come back the next day, and उसके बाद से मैंने उसको हरा पेंट कर, green paint. Then I go back, then I come back the next day with blue paint. And I keep on doing this. I keep on doing this for, let's say, 20 years. Every day I come in and I paint and I go back, and the next day I come in. 20 years. After 20 years, I will have a solid sphere. I hope you'll all agree. And the radius of this solid sphere will be larger than the radius of the marble. It will, in fact, it will be quite larger than the radius of the marble. Let's say कि फुटबॉल के साइज का हो गया, बास्केटबॉल के साइज का हो गया. Now, if I cut this basketball size sphere in half, and I look at the cross section, what will I see? If I cut this basketball size sphere in half and I look at the cross section, what will I see? I will see the different layers of paints that have made up the sphere, right? Now let's forget about the marble. Let's say that the marble that I took initially was that of 0 radius. Okay, you can ask, अरे ऐसा कैसे हो गया? हाँ, ऐसा हो सकता है. तो जो मैंने पहला पेंट किया, that was on a sphere of radius dr, an infinitesimally small sphere I made, and then उसके ऊपर पेंट किया, फिर उसके ऊपर पेंट किया, करते 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 बास्केटबॉल बन गया. अब जब मैं उसको आधा काटा तो मेरे को पूरे लेयर्स ऑफ पेंट दिखाई दे रहे हैं, और एक सिंगल लेयर की थिकनेस infinitesimally small. Now suppose that I can do some magic. Physically impossible, therefore magic. Supposing that I can take out all these layers of paints without affecting the layer in any way. So for example, if the outermost layer is pink, तो मैंने जादू किया और मेरे को एक पिंक स्फीयर मिल गया मेरे हाथ में, और उसके नीचे का जो लेयर था वो ब्लू था, तो दूसरे हाथ में ब्लू स्फीयर मिल गया. अब मैंने फिर से मैजिक किया तो ब्लू स्फीयर बाहर आ गया, उसके नीचे रेड था तो रेड सॉलिड स्फीयर मिल गया, और मैं ऐसे करते गया. What will I end up with? I will end up with a huge number of hollow spheres. And what will be so special about the radius if I keep them adjacent to each other? What will be so special about the radius? Well, the radius will keep on reducing. बहुत ही slight, ever so slight amount. In fact, if you look at two adjacent spheres, you will never say कि इन दोनों का radius अलग है. And if I have laid them out on a horizontal surface, supposing 1 किलोमीटर तक वो spheres चले जा रहे हैं, तो आप 500 मीटर वाला दूर स्फीयर देखोगे तो बोलोगे हाँ वो तो बहुत बड़ा है, ये बहुत छोटा है जहां मैं खड़ा हूं. लेकिन एडजेसेंट दो स्फीयर आप देखोगे तो आपको कभी रेडियस के बीच में नजर नहीं आएगा फर्क. Therefore, in physics, mathematically, we say that a solid sphere is made up of infinite number of hollow spheres. So a solid sphere is a continuous system, and every continuous system is made up of an element. I'm going to use this word a lot. every continuous system is made of an element. So for a solid sphere, the elements are hollow spheres of different radii. These are the elements of a solid sphere. अगर कोई कंटिन्यूअस ऑब्जेक्ट एक डायमेंशन में एग्जिस्ट करता दिखाई देता है, अगर कोई कंटिन्यूअस सिस्टम एक डायमेंशन में एग्जिस्ट करता दिखाई देता है, अगर कोई ऑब्जेक्ट हमको एक कंटिन्यूअस ऑब्जेक्ट एक डायमेंशन में एग्जिस्ट करता हुआ दिखाई देता है, what we can do is we can take a sword, imaginary of course, और जैसे फ्रूट निंजा खेला है किसी ने, फ्रूट निंजा, आई होप एवरीबॉडी हैज प्लेड, आई डोंट नो, मे बी इट्स टू ओल्ड फॉर यू गाइस. अच्छा खेला है क्या? हाँ. तो फ्रूट निंजा में जिस तरीके से तलवार से फ्रूट को काट देते थे, उसी तरीके से व्हाट आई एम गोइंग टू डू इज दैट आई एम गोइंग टू टेक अ स्वॉर्ड and I'm going to cut it like this. And then I'm going to choose one and I'm going to say that this guy is so small that for all practical purposes this is a point particle, and this is the element of a continuous object which is existing in one dimension. But ये तो सब थ्योरी है, फिजिक्स कहाँ है, मैथ्स कहाँ है? मैथ्स ये रहा. Whenever I choose an element, I will have to say that look, this element is at a distance of x from this end of the chain or the object, continuous object, and therefore the width of the object will be taken as dx. Right? This is the key statement. The statement is that element is at a distance x from one end, therefore its width is dx. It's very important to have the same variable. You can't choose another variable. You can't say the element is at a distance of L from one end and therefore its width is dy. नहीं, ऐसा नहीं काम चलेगा. If it is at a distance of L from one end, then its width is dl, nothing else. Once you have converted a continuous system into an element, set of elements, exactly, yes. Once you have converted the continuous system into a set of elements, and out of those set of elements you have chosen one, then you can apply whatever mechanics we have learned on that one guy. Okay, and then you can say that whatever I have calculated for this one guy will hold true for all the other guys, and therefore whatever I have calculated, the sum of that must be true for the whole object. And the moment you say sum and dx in the same sentence, you are basically doing what? You are basically going to do what? You are basically going to integrate. Okay? You are going to integrate. Now this process will always be the same. Okay? You will have a continuous object, you will break it down into elements, and then for one element you will find whatever it is you want to find, whatever physical quantity it is you want to find. And then you will integrate that physical quantity to find the effect or the physical quantity for the whole object. जिस तरीके से अर्जुन की कहानी याद है किसी को? वो द्रोणाचार्य ने he gave this task to all the guys that वो चिड़िया को मारना है तीर से, राइट? तो पहले वो पूछा, द्रोणाचार्य ने किसी से पूछा कि तेरे को क्या दिखाई दे रहा है? उसने बोला, अबे मेरे को तीर 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 की नोक दिखाई दे रही है और सामने चिड़िया दिखाई दे रही है और पेड़ दिखाई दे रहा है और खेत दिखाई दे रहा है। तो द्रोणाचार्य ने बोला, तू रहने दे बेटा, उससे ना हो पाएगा, तू आगे बढ़। फिर दूसरे को बुलाया, हाँ यस एग्जैक्टली। तो दूसरे को बुलाया, उसने बोला तेरे को क्या दिखाई दे रहा है? तो बोलता नहीं, मेरे को चिड़िया दिखाई दे रही है। द्रोणाचार्य ने बोला, तुझसे भी नहीं हो पाएगा, तू आगे बढ़। But when Arjun came and Dronacharya asked, what do you see? He said, I can only see the eye of the bird. I can't see anything else. I only see that object which I have to hit. In the same way, once you have divided the continuous object that is given to you into elements, and once you have chosen a particular element by this method that I've just showed you, then all you should see is that element. और कुछ नहीं दिखाई देना चाहिए। Okay? All you should see is that element, nothing else. So using this knowledge, let's try to solve this guy. Acha, slowly is very important. Whenever I use the word slowly in physics, either I'll use slowly or I'll use static. This implies that there is no change in kinetic energy. What does this mean? So I will say that I will push this block up the incline. Okay? I will push this block up the incline. But in a very weird way. And that weird way is that I have applied a force mg sine theta on the block. Gravity has applied a force mg sine theta on the block. I'm balancing the force. I'm just balancing the force. At some point of time, I will increase the force that I have applied by an infinitesimally small amount. Due to this, the block will move up the inclined plane by an infinitesimally small amount and I will stop. Okay? I will stop for, I don't know, I will stop for a year or so. And then after 1 year again, I will push it ever so slightly and then I will stop. Since I'm very patient, as you saw with the painting of the marble, I will keep on pushing this block an infinitesimally small amount year after year after year after year. So that if ever you come inside the room where this experiment is going on and you stay for a while, you will always conclude that the velocity of the block is 0. However, if you come back after 20 years, if you come back after 200 years, you will find that the block has shifted from position A to position B. Maybe the block has shifted from this point to this point. So whenever you come inside and you try to measure the velocity, 0. But if you come after a large amount of time, then displacement has occurred. Okay, this is what we mean by slowly. Basically, mathematically, it means that kinetic energy does not change. Okay, so let us chop this up, slice this up. Idhar, idhar. Now, which element should I choose? Well, this guy, okay, this guy, I find very uninteresting. I don't like this guy. I don't like this guy. I don't like this guy because nothing is going to happen to this guy. क्योंकि फोर्स तो लेफ्ट पे लगा है. As time goes on, ये चेन तो ऊपर चढ़ती जाएगी ना टेबल पे. ये जो मैंने ग्रीन बंदा अभी बनाया है, जो मैंने ऑब्जेक्ट बनाया है, जो मैंने पार्टिकल बनाया है, जो एलिमेंट बनाया है, वो हॉरिजॉन्टली चलता रहेगा. So I'm not really interested in that. I am, however, interested. In this guy. Why should I be interested in this guy? Because as time goes on, this guy will be doing what? This guy will be moving up. Okay. Now comes the most important part. X and dx. X कहाँ से लेना चाहिए, dx कहाँ से लेना चाहिए? Well, x is an arbitrary distance, right? Arbitrary distance to what? Well, it's the arbitrary distance to your chosen element. So the next question should arise from where? And the answer to that is it should be from a fixed point. It should be from a fixed point. It should be from a point for which you have some information about. So here we have 3 points of interest. Here we have 3 points of interest. One is this point, which is the end of the chain. One is this point, which is the other end of the chain. And one is the edge of the table. मैंने डॉट यहाँ बना दिया है, but ये डॉट यहाँ है actually. One is the edge of the table. You can choose any points. And like I said, I think I discussed this in the last class or last to last class, that depending on your choice of variables, the problem will become, or the maths will become easier. Right? So if it becomes very lengthy, if it becomes tedious, then you will have to be more attentive, you'll have to be more careful, and that also takes a toll. So I will say that from here, this distance is x, and therefore this is ds. अब अर्जुन की तरह मेरे को कुछ नहीं दिखाई दे रहा है, केवल वो लाल डॉट दिखाई दे रहा है. शौनक अभी बोला ना तेरे को, अगर x लिया है तो dx लेना पड़ेगा, अगर मैं l लेता तो dl लेना पड़ता. चेन का मास m है, लेंथ l है, ये लेंथ l एक नंबर है, ये फिक्स्ड क्वांटिटी है, ये x एक वेरिएबल है, dx भी एक वेरिएबल. नेवर गेट कंफ्यूज्ड. एक्चुअल लेंथ दिया हुआ है, उससे हमें कोई लेना देना नहीं. ठीक है ना? चिड़िया की लेंथ क्या है, उससे कोई लेना देना नहीं, आंख से लेना देना. हाँ, dx is a variable. Of course, dx is a variable. So, just like that guy Arjun, I can only see the red dot. And I want to find out the work done by the earth on the red dot in this whole process where the chain is pulled down. So when the chain is pulled up, then just like Arjun, remember, मेरे को यहाँ दिखाई दे रहा है और फाइनली मेरे को यहाँ दिखाई देगा. ये इनिशियल है, ये फाइनल. ये आया समझ में? इनिशियल फाइनल जो मैंने बनाया है, अगर ये फोर्स F इस चेन को लेफ्ट खींच रही है तो इवेंचुअली द होल चेन विल बी ऑन द टेबल, and therefore the red element that I have chosen will also be on the table. So I have drawn the initial and final positions of the element that I have chosen. Then I write, please notice the terminology here, dW. dW is the small amount of work done on, oops, sorry, on chosen element. So dW earth is equal to dmg minus, where this is the mass of the chosen element, into the vertical distance between initial and final points. This is easy. This is x. X. Okay. Now, to find dm, we use the unitary method. Let's use the unitary method. Length L में mass m है. Length L में mass m है. Unit length में mass m by L होगा. dx length में mass m by L into dx. So dW by earth is equal to minus m by L gx dx. Please take a screenshot. Please take a screenshot. So dW earth is equal to minus m by L gx dx. Therefore, work done by the earth on the chain should be the sum of work done by the earth on each of the individual elements should be equal to minus m by L gx dx integration. But this is not the end. This is not the end. No, no, no. So there are other distinct steps here to be done. The final step before you carry out the actual integration, the final step before you carry out the actual integration is you have to find the limits, because remember I told you कि physics में integration without limits हम नहीं करते. तो जो एलिमेंट हमारा यहाँ पे है और जो एलिमेंट हमारा यहाँ पे है इसके लिए x की क्या वैल्यूज, इसके लिए x की वैल्यू 0 है और इसके लिए x की वैल्यू 2l/3. So I want to find out the work done by the earth on this guy, on this guy, on this guy, on this guy obviously, and on this guy, and all these guys who are vertically here. Because horizontally all the guys, the work done by earth is going to be 0. You can calculate that as well, but it's just it's doing nothing. Horizontally जा रहा है, work done by earth is 0. Element ले लो आप, चाहे पूरी chain ले लो. So this means that the limit will go from 0 to l/3. And you integrate this, you get minus m/lg into x square by 2, 0 to 2l/3, minus mg by l into कितना आएगा 2l square by 9, right? This will be equal to 2mgl minus 2mgl. Now, for the whole chain, नहीं, xi और xf की बात नहीं है आप, ना. x देखो कहां से कहां तक वेरी कर रहा है. x चीज क्या है, x है क्या चीज, x is the distance of this red element from the edge of the table, right? Therefore, what is the distance from the edge of the table of the first element here, and what is the distance from the edge of the table for the last element here? That is how you decide on the limits. Okay. So for the chain then, we have work done by earth plus work done by F is equal to 0. Right? Since this was a slow process. This implies that work done by force must be minus of work done by earth must be equal to 2mgl. So of all the lectures that I give, this perhaps is the most important one. And I will revise this for you and I will make you write down the steps. Okay? I will make you write down each and every step that I have done here. And these steps, they are beyond this chapter. They are applicable for every continuous system that we are going to see. And beyond this chapter, the only thing that we are going to see will be continuous systems. So whether it is center of mass, whether it is rigid body dynamics, whether it is electrostatics, whether it is magnetism, all the chapters from now on will have invariably the concept of continuous systems. Okay. Chalo, so I'll stop here, right? बोल के हाँ एक मिनट हाँ
सर जो आपने क्वेश्चन 1 दिया था आप उस पे जाएंगे?
क्या हो गया, गलत कर दिया क्या?
सर इसमें cos थीटा की वैल्यू 1/3 आई थी, तो नॉर्मल नीचे की तरफ लगेगा ना ट्यूब पे?
क्यों भाया?
बॉल नीचे लगाएगा ना नॉर्मल?
अरे तो कहाँ करुण, cos 0 कितना होता है?
1.
फिर एंगल बढ़ता जाता है तो cos की वैल्यू
कम होती है.
और मत चिंता कर, मैं भी इसमें बहुत फंसता था, अगर कोई एकदम दिमाग खराब हो जाता था. समझ में आ गया ना तेरे को? Chalo. So Pratiksha had sent some doubts which I think I need to answer for everyone. The first question is, no work is done by a force on an object if the force is always perpendicular to its velocity, right? Work done will be zero because velocity is equal to displacement upon time, right? So if something is proportional to, if something is perpendicular to velocity, that something is perpendicular to displacement. The force is always perpendicular to acceleration. No work can be done, no problems here, because acceleration and velocity don't have the same direction. They don't have to have the same direction. Acceleration is having the same direction as change in velocity. The object is stationary, but the point of application of force moves on the object. So it's just like you keeping your pencil box on the table and moving the pen on the pencil box, but the pencil box itself does not move, right? It's like me writing on the board, and I write something on the board with a marker. So marker obviously moves on the board, but the board itself does not move. And the work done on that object uh, uh, will be zero. Okay, work done on the pen will not be zero, but work done on that object will be zero. The object moves in such a way that the point of application of the force remains fixed. Okay. The object is now moving, but the point of application that remains fixed. In this case, also work will not be done. An example would be climbing the stairs. When you are climbing the stairs, then work done by normal reaction is zero because your shoes, your feet, they do not move on the stairs. Okay? They are always in contact with the stairs. But you are moving up. फिर second question है, the kinetic energy of a particle continuously increases with time. The resultant force on the particle must be parallel to the velocity at all instants. No, does not have to be parallel. Only one component is required. The resultant force on the particle must be at an angle less than 90 degrees all the time. Okay. So kinetic energy of the particle is continuously increasing with time. This means that the component of the net force must always be along the velocity. This is true. Its height above the ground level must continuously decrease. इसका कोई मतलब नहीं है. Magnitude of its linear momentum is increasing continuously. That is okay. mv is increasing, so half mv square is increasing. A particle is acted upon by a force of constant magnitude which is always perpendicular to the velocity of the particle. The motion of the particle takes place in a plane. It follows that its velocity is constant, not possible, force is acting on it. Its acceleration is constant, not possible, otherwise the force would never be always perpendicular to velocity. Its kinetic energy is constant, yes, because force is always perpendicular to velocity. This means that the kinetic energy can never change. Work done will be zero. Okay? And the fourth point is that it moves in a circular path. Okay? It moves in a circular path. I don't think that should be. हाँ yes I moves in a circular path. ठीक. अगर और forces act कर रही हैं तब फिर गड़बड़ है. But only a single force is acting such that it is always perpendicular to its velocity, then it will move in a circular path, especially if it is in a plane only. ठीक है. दीक्षा ने नहीं पूछा था, किसने पूछा ये? अच्छा तरुण ने पूछा था. नंबर मिक्स हो गया. चलो कोई बात नहीं. बट ये क्वेश्चंस अच्छे थे. चलो ओके, आई विल सी यू इन द नेक्स्ट क्लास। आ गया ना तरुण समझ में तेरे को? बाकी लोग को भी आ गया? ये एक्चुअली मैं डिस्कस करूंगा जब हम सेंटर ऑफ मास वाला चैप्टर पढ़ेंगे। See what is happening is that I have taught you what is the concept of work done on point objects. But हमारी लाइफ में, हमारी दुनिया में तो पॉइंट ऑब्जेक्ट्स होते ही नहीं है। हमारी लाइफ में तो सब एक्सटेंडेड ऑब्जेक्ट्स होते हैं। So today was the first step towards dealing with extended objects. And in स्क्रीनशॉट नहीं लिया क्या आयुष? अच्छा चल मैं भेजने की कोशिश करता हूँ। So today is the first step that we took towards the study of extended objects, and now we are going to study more and more extended objects. Ultimately, we'll be studying only extended objects. So I will discuss these points once again. What is the concept of work done on extended objects? Okay. Chalo, I'll see you guys later in the next class. कोई क्लास नहीं है ना इसके बाद? मैं एंड कर रहा हूँ मीटिंग। ओके, चलो बाय बाय।